8051 microcontroller. DC motor converts electrical energy in the form of direct current into the mechanical energy. In the case of the motor, the mechanical energy produced is in the form of a rotational movement of a motor shaft. The motor can be rotated at a certain speed by applying a fixed voltage to it. If the voltage varies, the speed of the motor varies. For reversing the current, we can make use of H-bridge circuit. For the motor IC that employ the H-bridge technique or any other mechanisms.
Circuit principle of 8051 DC motor interface. Maximum output current of a microcontroller pin is 15 mA at 5 volt, but the power requirement of most of the DC motor is out of the reach of the microcontroller, and even the back EMF that is generated by the motor may damage the microcontroller. So it is not good to interface the DC motor directly to the controller. So we should use a driver circuit in between a DC motor and a microcontroller.
Here is the circuit where DC motor is connected to the L293D IC, and here is the components required.
Circuit design. The major components in the above circuit diagram are the 8051 microcontroller and the motor driver. DC motor is connected to the output terminals of the L293 driver, and the enable pin is connected to the 5 volt DC to drive the motor. Here, two pins of port 2, that is pin P2.0 and pin P2.1 are used for driving the motor. The logic implemented is when the pin P2.0 is high and set to 1, the motor rotates in the forward direction. Whereas the pin P2.0 is low, the motor rotates in the backward direction. Assembly language program for DC motor. Here, L293D motor driver is used for interfacing 8051 microcontroller. Here, driver L293DA is equated to pin P2.0 and L293D B and C is equated to pin P2.1 and 2 respectively. Next, function A call is used for calling the subroutine located at the specified address, that is rotate F and rotate B, and SGMP main function is used to stay in the loop. The logic behind the implemented code is when P2.0 is high and set to 1, whereas the pin P2.1 is low, the motor rotates in the forward direction. Whereas the pin P2.0 is low and the pin P2.1 is high, the motor rotates in the backward direction. At last, when the all pins are clear and set to 0, the motor stops.
Embedded C program of DC motor with a lamp or a light. At the very beginning of the program, I have declared the header file of generic family of Atmel 8051 or 8031. I have considered 3 sensors or 3 buttons of the port 1, that is the pin number 1, 2, 3 of port 1 0, port 1 1 and port 1 2, and have considered 3 loads. It may be 2 lamp or a DC motor, that is port 2, that is of pin number 21, 22 and 23, that is port 2 0, port 2 1 and port 2 2. Next, opening the void main, if I have considered all the loads to be equal to 0 and all the sensing element to be equal to 0. While this condition is true, I have opened an infinite loop. If one of the sensor is activated, then the corresponding load is activated. That means it is in a high condition or it is in the on state. If sensor 1 is in high, then the load 1 corresponding to it will also be high. Similarly for sensor 2 or button 2 or sensor 3 or button 3.
Here, the motor drive input pin IN1 and IN2 are connected to the P2.0 and P2.1 respectively to control the motor directions. DC motor is connected to the output terminals of L293D. EN1 pin is connected to the 5 volts DC to drive the motor. Here P2.0 pin is high, the motor is in forward rotation. If P2.1 pin is high, the motor is in backward rotation.